Good day. Welcome to my YouTube channel, and today I will be discussing about quantitative research design as well as sampling procedures and sample. At the end of this discussion, you are expected to choose appropriate quantitative research design and describe sampling procedure and the sample. First, we will define quantitative research design. According to Barrett, research design is defined as the logical and coherent overall strategy that the researcher uses to integrate all the components of the research study. In a good research design, all the components go together with each other in a coherent way. Basically, a research design means the plan or technique of shaping your research study. If the theoretical and conceptual framework must fit with the research goals and purposes, in the same way, the data gathering method must fit with the research purposes, conceptual and theoretical framework, and method of data analysis. And by doing that, you need to choose appropriate research design for your research study. Therefore, research design will give meaning in the overall process of your research. Now, we will discuss the two types of quantitative research design. The first one is non-experimental research design, and the other one is the experimental research design. When we say non-experimental research design, it is a type of research that does not involve the manipulation of control variables. While in experimental research design, it is a type of research that uses a scientific approach towards manipulating one or more control variables and measuring their effect on the dependent variables. Actually, the main distinction in these two types of research is their attitude towards the manipulation of control variables. Experimental allows for the manipulation of control variables, while non-experimental research does not manipulate control variables. Next, let us have example for non-experimental research design. You want to investigate whether there is a relationship between the variables of income and happiness. So you have two variables, income and happiness. You hypothesize or you guess that income level predicts happiness, but it is not practically possible to manipulate the variable of income. That is why it is under non-experimental research design. Instead, you use a survey to collect data about income and happiness. Next, about experimental research design, you want to study the effectiveness of vitamin D supplements on improving alertness. You design an experiment with a control group that receives a placebo pill and an experimental group that receives the supplement. Your independent variable is whether vitamin D improves alertness or vitamin D supplement improve alertness, and your dependent variable is the level of alertness. Here, to make sure any change in alertness is caused by the vitamin D supplement and not by other factors, you control or you manipulate these variables that might affect alertness, like diet, timing of meals, caffeine, or even screen time. Now, what do we mean by control variables? It is anything that is held constant or limited in a research study. It is a variable that is not of interest to the study's aims, but is controlled because it could influence the outcomes. Variables can be controlled directly and indirectly. Variables may be controlled directly by holding them constant throughout a study, like controlling the room temperature in an experiment, or they may be controlled indirectly through methods like randomization or statistical control. Example, you have this research question: does soil quality affect plant growth? And your control variables would be the temperature, amount of light, amount of water. You can control this variable by increasing or decreasing the temperature, amount of light, or even the amount of water, because you think that these variables could affect the outcome of your research. So, controlling variables could enhance the internal validity of your study by limiting the influence of confounding and other extraneous variables. This helps you establish a correlational or causal relationship between your variables of interest. Let us now have the distinction between control variable and the control group. Remember that a control variable isn't the same as a control group, because control variables are held constant or measured, like variables such as age, height, weight, amount of water, amount of light, temperature, diet, marital status, and the likes, throughout the study for both control and experimental groups. So as you can read, you will be having two groups, the control groups and experimental groups coming from your population. So you made a control group that will not, and this group will not undergo the experimental treatment of interest, and its outcome are compared with those of the experimental group. So outcome of control group will be compared to the outcome of experimental group. A control group usually has either no treatment, standard treatment that's already widely used, or a placebo. Under non-experimental research design is descriptive research, a study of prevailing condition. It is used actually to observe, document, and describe a phenomenon occurring in its natural setting without any manipulation or control. This approach is used to describe variables rather than to test a predicted relationship between the variables. So take note of this. It is used only to describe a variable, to observe and document in a natural setting without any manipulation or control. So it describes what exists and may help to uncover new facts. And in descriptive research, it has law on the control or manipulation of research context scale. So in descriptive research, it is non-intrusive and deals with naturally occurring phenomena. Example is food intake associated with pre-adolescent obesity, an observational study in Metro Manila, Philippines. So here, it does not deal with the cause and effect relationship. Instead, it is an observational study. Next, correlational research, also known as associational research. So, collects data and investigates to what degree is the relationship between two or more quantifiable variables without any attempt of manipulation. So here, it is just this describing the relationship between, or the magnitude of relationship between two or more quantifiable variables. So the relationship between variables can be described using the correlation coefficient, and the most common of which is the Pearson product moment of correlation coefficient. So it is used to either explore the extents to which two or more variables co-vary, that is, where changes in one variable are reflected in changes in the other. Example, the relationship between unemployment and increasing rate of suicide. Another, the relationship between low economical conditions and domestic violence. Next is ex post facto research or causal comparative research. Ex post facto means after the fact. So investigation starts after the fact has occurred. Manipulation is not possible. So it is used in studies which measure the pre-existing effects. Example, cause of delinquency, earthquake hit area. And then it is much research in medicine and sociology. So we have actually two types of causal comparative study, the retrospective causal comparative research and the prospective causal comparative research. So retrospective, it investigates a particular question when the effects have already occurred and attempts to determine whether one variable may have influenced another variable. Prospective causal begins with the causes and investigate the effects of a condition. So example, how does having a working mother affect a child's school absenteeism? So another, exploration of effects caused by membership in a group. What differences in student behavior are caused by gender? Another, studies the consequences of an intervention. How do students who have taken EME 001 evaluate research articles on what are the effects of teacher gender and student behavior? So those are the example of ex post facto research. Under experimental research design is quasi-experimental research. From the word quasi, it means resemblance, so almost an experimental design. It involves selecting groups upon which a variable is tested without any random pre-selection process. So it uses selected independent variable because random assignment is not possible. Thus, researcher cannot randomly assign participants to groups, and for that it lacks control over extraneous variable. And quasi-experimental research often used in applied research. Example of quasi-experimental research: in a study of the effectiveness of a new management technique, one branch office is given a new TQM method to implement, so that is the experimental group. Another branch office retains the traditional management policy, so that is the control group. A quasi-experimental study of the effect of mathematics professional development on student achievement. Another example, people with cancer versus no cancer. Management style A versus management style B. One type of farm equipment versus another. Next is true experimental research. True experimental research relies on a statistical analysis to prove or disprove a hypothesis, making it the most accurate form of research. And random assigning allows for better results from treatment. It establishes also cause and effect relationships. So experimental designs are used in order to find a cause and effect between two variables. It contains three criteria. It should has controlled experimental group, it should has research manipulated variable, and random assignment. And this experimental research method commonly occurs in the physical sciences. So quasi-experimental often used in applied research. Through experimental research, it is commonly used in physical sciences. Example, laboratory experiments that involve mixing different chemical elements together to see the effect of one element. So here, the independent variable can be manipulated by the researcher against the dependent variable. And let us have the distinction between true experiment and quasi-experiment. When the research questions deals with what happens if subject can be randomly assigned to groups, then you will use experimental design. And what happens if subjects cannot be randomly assigned to groups, you will use quasi-experimental design. But we also have this after-only design and post-test design. In experimental design, if you cannot collect pretest data, then it is on after-only design. But if you can collect pretest data, it is pretest post-test design. Same with quasi-experimental design. If you can collect pretest data, it is a pretest post-test design. And if you cannot collect pretest data, it is after-only design. So quasi-experimental design, particularly pretest post-test design or after-only design. Next, is random assignment used? If yes, randomized or true experiment. If no, there is a further question. Is there a control group or multiple measures? If there is a control group, quasi-experiment, but if your answer is no, you will proceed with non-experiment. Next, both in true and quasi-experiments, you will use intervention, or you will implement intervention or treatment. In true experiment, there is a high degree of control because of random assignment. In quasi-experiment, there lacks a degree of control because of random assignment. In true experiment, it includes a comparison group, same with quasi-experiment. But in quasi-experiment, for non-equivalent group, and for true experiment, for controlled group. For true experiment in natural setting, can be difficult to obtain permission and access because it is good for quasi-experiment, and this one, true experiment, is good for true experimental design. To sum it up, in true experiment, independent variable is manipulated and subjects are randomly assigned to conditions. In quasi-experiments, independent variable is manipulated but subjects are already part of a group based on pre-existing characteristics. Now, we will proceed with the sampling procedure and the sample. When we talk about sampling procedure and sample, we will discuss about population. And the definition is, it is a totality of all the objects, elements, persons, and characteristics under consideration. But we have two types of population. We have the target population and then the accessible population. When we talk about target population, it is the actual population. Example, all senior high school students enrolled in accountancy, business, and management is run in the division of Bataan. While accessible population, it is a portion of the population in which the researcher has reasonable access. Example, all senior high school enrolled in ABM Strand at Bataan National High School. So, for the researcher, it is accessible for him to get the population of all senior high school enrolled in Bataan National High School instead of all senior high school students enrolled in ABM Strand in a division of Bataan. Next, we will talk about sample. It is a sub-collection of elements taken from the population. From the word taken, sample is just a part of your population. So, the act or process of selecting sample from population for testing, analyzing, interpreting is what we call sampling. We have two types of sampling procedure. The first one is probability sampling. This sampling provides an equal chance of participation in the selection process given to every member listed in the sampling frame. Actually, it involves random selection, allowing you to make strong statistical inferences about the whole group. First, under probability sampling is a simple random sampling or simple probability sampling. It uses a pure chance selection process because of using fishbowl technique, roulette wheel, or lottery method. Using this technique, your population or all elements in your population will have an equal chance of being selected to be part of your research. Example, you have a total population of 800 and a sample size of 260. As a researcher, you may write all 800 names in a clean sheet of paper, place it in a bowl, and draw 260 papers out of the bowl. So in this procedure, as you can see, it does not have any biases. So you has a pure chance selection process. Second, systematic probability sampling. It uses sampling interval that will be used as quasi-random selection method. Sampling interval equals population size over sample size. So 800 divided by 260, it will give you a sampling interval of 3. At first, you will write all the names of your participant in a clean sheet of paper, and then you select participants for every third sampling unit in the list. In this sampling interval, it produces a random selection from throughout the total population. Next is stratified probability sampling. It involves dividing the entire population into homogeneous groups called strata. So, you will divide first your population into groups having same characteristics. Then, a random sample from each stratum is taken in a number proportional to the stratum size when compared to the population. You will get sample from each group using random sampling. And then, to find number proportional to population size, you will use this stratified random sampling. The formula is total sample size over entire population times population of subgroups. So, example, total sample size of 260 divided by 800 times 400, you will get sample of 130 participants from UMS. In STEM, you will get only 97 participants, and in ABM, you will get only 33 participants. And these numbers proportional to each stratum size. Next is cluster probability sampling. It divides the population into groups, usually geographically. The groups are called cluster. From our example, the population is divided into 4 groups. The clusters are randomly selected. So, using random sampling, we choose 2 groups, and then it is the group 1 and then the group 4. So, we have population size of 800, sample size of 260. So, the researcher can randomly select 130 participants from each cluster to represent the sample. For non-probability sampling, according to Edmond 2013, the subjects are chosen based on the availability or the purpose of the study. In some cases, it is a discretion of the researcher. Actually, it involves non-random selection based on convenience or other criteria, allowing you as a researcher to easily collect data. First is quota sampling. It is used when the researcher knows the characteristic of the target population. First, it divides the population into subgroups according to relevant control characteristics. Then, just like in stratified random sampling, then define the proportion of the subgroups in order to decide how many elements will be chosen from each subgroup or quotas. Next, select an appropriate sample size and then select elements from subgroups. Example, you have a total population of 200. It consists of 100 males and 100 females. And then you only need to have 100 samples. And then you decide to have a 25% males and 75% females. For tally sampling, a sampling technique wherein the subjects for the study are the ones volunteering to be part of the sample. That is why it has no selection process. Example, the researcher puts out a request from the members of the population to join the sample, and the people will decide whether or not to be in the sample. Next, purposive sampling, also known as judgmental, selective, or subjective sampling, a form of non-probability sampling in which researchers rely on their own judgment when choosing members of the population to participate in their surveys. Example, researchers went to a community on purpose because they think that these individuals fit the profile of the people that they need to reach. Remember that in non-probability sampling, elements from the population are chosen on a non-random basis, and all members of the population do not have an equal chance of being selected to be a part of the sample group. Next is convenience sampling, also known as availability sampling. People are sampled simply because they are convenient sources of data for researchers. It is used when the researcher automatically includes the persons who show willingness to participate in the study. Example, standing at a mall or a grocery store and asking people to answer questions. Next is snowball sampling, also known as chain referral sampling. Existing subjects provide referrals to recruit samples required for a research study. Example, if your study requires responses from ex-convicts, it would be difficult to get an adequate number of people who are willing to participate in your study. However, if you could invite a few ex-convicts to be part of your research, they could help you get in touch with others in their group. When to use snowball sampling? You will use snowball sampling when you do not have any means of contacting the bulk of your target population, and when you know where your target population is but it's difficult to get in touch with them, and when members of the target populations are victims of social stigma and are less interested in contributing to your research. Again, snowball sampling is a non-probability sampling technique in which the samples have traits that are rare to find.